Hey guys, today we're going to be learning how to solve quadratic linear systems algebraically. So we've done this in the past, but this should be review. And we did this yesterday, but with graphing. So yesterday we graphed a parabola, also known as a quadratic, and then we also graphed a linear function, which is a line, and then we figured out what are the 2 points, typically 2 points, where they intersect. So now we're going to be doing the same thing, but we're going to be using algebra to figure that out. So we're only going to do 2 examples. So the first example we have is y equals x squared plus 2x minus 2. And then the other equation, the linear, is y equals x plus 10. And what we need to do is we need to figure out a way to put these 2 equations together to determine the intersection points. So we're technically going to be using the substitution method because since both of these equations are equal to y, we can set them equal to each other. So we're going to have x squared plus 2x minus 2 set equal to x plus 10. Now, whenever you're dealing with x squared, any type of quadratic, you always want to set the equation equal to 0 first. So to set it all equal to 0, it's easier if we have a positive x squared term. So I'm going to move the x to the other side by subtracting. And in the same step, I can also subtract the 10 to move that to the other side of the equation. And then what I'm left with is x squared plus x minus 12 equals 0. Now from here, there's a bunch of different ways that we can solve this algebraically. We can use the quadratic formula. The quadratic formula will always work. It will take a little bit more time than some other options, but it's typically a fan favorite just because it's an equation that you can substitute everything in and it always works out. So this is the quadratic formula in case we need to remember it. Negative b plus or minus b squared minus 4 times a times c all over 2a. Now, if you don't want to use the quadratic formula because you think it takes too long or whatever the case might be, you can check to see if it's factorable, so if you know how to factor. So, when factoring, first you ask yourself, is there a GCF? So, in this scenario, there's not. So then you move on to the fact that this is a trinomial. So it's trinomial because there are 3 terms. And your a value is 1 because there's nothing in front of that x squared. So to factor this, you list the factors of c, which in this case are 12, until you find the factors that add up to your b value, which is 1. So if we list the factors, we'll start with 1 and negative 12, 2 and negative 6, 3 and negative 4, and I've hit them all aside from switching the negative around. So I'll write those as well, just so you can have a full picture. Negative 1, positive 12, negative 2, positive 6, and negative 3, positive 4. Once you have all your factors listed, figure out which one adds up to b, so which one adds up to a positive 1, and that should be negative 3, positive 4. So because negative 3 and positive 4 add up to 1, we now know how to factor it. We're going to have 2 sets of parentheses equals 0. To break up x squared, we have x and x. And since we know -3 and +4 are the factors that work, those go in the parentheses. After you have factored, you are going to set each factor equal to 0. So you have x minus 3 equals 0, or x plus 4 equals 0. And then you're going to solve for x. So in the first equation, to get x alone, you're going to want to add 3 to both sides. And so you end up with x equals 3 as one of your x answers. And then in the other equation, to get x alone, you're going to subtract 4 from both sides, and you end up with x equals -4. Now you did all that work, so you might automatically assume that you're done. However, remember that you're looking for ordered pairs. So you need an x value and a y value. So, since you found 2 x's, you need to find 2 y's that correlate with those specific x values. So you're going to look back at the original equations, and you're going to choose the equation that you find easier to work with. So personally, I would choose this y equals x plus 10 equation, and what you can do is you can substitute the values you got for x. So one of them will be y equals 3 plus 10, and the other one would be y equals -4 plus 10. And when you add these together, you'll get a y value of 13 that goes with the x value of 3, and a y value of 6 that goes with the x value of -4. So your final answer, I know this is a lot of work, but your final answer needs to be written as ordered pairs. So your answer should be 3, 13, and -4, 6. And those are your 2 ordered pairs where the functions are going to intersect. Okay. Now, if you don't like factoring, on the next page, I'm just going to show you how you would use the quadratic formula to find the x values. So, if you don't want to relearn this or see this, you can feel free to skip ahead to question 2 in the video. But just for the sake of practicing, because I know not everyone likes to factor, we're going to do the quadratic formula with this specific question. So, what we have to remember is I'm going to write the quadratic formula again. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. And I'm going to write the equation down after I combined the 2 original equations and set it equal to 0. Remember, I had x squared plus 2x minus 2 equals 0. Oh wait, that was the original. Disregard that. So once I combined them, I ended up with x squared plus x minus 12 equals 0. Okay. So from here, I have to figure out what is a, what is b, and what is c. So a is always the number that's in front of x squared. So a is 1. B is always the number that is in front of x, so b is also 1. And then c is the number at the very end with no variable attached, so c is negative 12. Now when we plug these values into the formula, we will have x equals negative 1 and then we have plus or minus the square root of, your b value is 1, and then we're going to square it, minus 4 times our a value, which is also 1, times our c value of negative 12, all divided by 2 times our a value of 1. So when we clean this up, we get x equals negative 1 plus or minus the square root of something all over 2, because 2 times 1 is 2. Now when we figure out what's inside of the radical, we've got 1 squared is 1, and then 4 times 1 times negative 12 is 48. So 4 times 1 times negative 12 is negative 48. 1 minus negative 48 turns into 1 plus 48, and that is going to give us 49. But you can just type that into your calculator if you don't want to try to do it in your head. And then the square root of 49, since that is a perfect square, that's going to give us a nice answer of 7 all over 2. Now the plus or minus allows you to break it up into two parts. One part would be adding, and the other part would be subtracting. So we end up with negative 1 plus 7, which gives us a positive 6, and positive 6 divided by 2 is going to give us our x value of 3. And then on the other end of it, we have negative 1 minus 7 is negative 8. Divided by 2 is going to give us our x value of negative 4. So our two x answers were 3 and negative 4, which we've already figured out. And if you were to do it this way, then you would go back, use whatever equation that you wanted from the beginning, probably the y equals x plus 10, and then do the same thing that we did to find that y is 13 and your other y value is 6, so your ordered pairs are 3, 13, and negative 4, 6. Okay, on to question 2, our final question. So for question 2, we have the equations y equals x squared plus 1 as our quadratic, and our linear equation is y equals x plus 1. Now, like we did before, we are going to combine these two equations. Since they're both set equal to y, we can set them equal to each other. And then we just have to get them all on one side so it's set equal to 0. So we're going to subtract x and subtract 1. Now, when you subtract x, there's nothing to combine it with, so it's going to stay just minus x. But 1 minus 1 gives you 0, so there's nothing there. And then we have 0 on the other side of the equation. Now, we can either do the quadratic formula, which works every time, or we can factor it. I'm going to choose to factor it because, again, it is typically the quickest way. And we first ask ourselves, is there a GCF? So in this scenario, there is. The greatest common factor, the term that goes into all the terms listed in this scenario, is x. So since x is my GCF, that gets pulled out in front of the parentheses. And to figure out what goes in the parentheses, I'm going to divide every term by x. So x squared divided by x is x minus x divided by x is 1. Now that I have factored, I need to set each factor equal to 0, and you'll notice that one of my factors is already solved. X equals 0 is one of my answers. The other equation just needs one step to get x alone, so we're going to add 1 to both sides, and my other x answer is x equals 1. Now I need to find the y values, so I'm going to use the easier equation, which is this y equals x plus 1, to figure it out, and I'm going to use each of the different x values. So I have 0 that I need to substitute in, as well as 1. So I end up with y values of 1 and 2. And then my final answer has to be written as an ordered pair. So I end up with the ordered pair 0, 1 and 1, 2. And I'm just going to bubble it in so it stands out a little bit. And that's it. That's all we have to do for our notes for today.